look at how to graph parabolas, given all the information that we've learned. The important things to remember is the axis of symmetry that leads to the vertex. Once we have the axis of symmetry, x equals, we can take that x, plug it into the original equation, and find the y for the vertex. The y-intercept is where x equals 0. Not quite as important, but it's fairly important at this point. X-intercepts, if any, we're going to learn how to find those later. But let's for now focus on the axis of symmetry, maybe the y-intercept to graph our equation. So finding the axis of symmetry in this equation, we would look at the formula, negative b over 2a, that's what x is. Negative b, a negative negative 4 is a positive 4, and 2 times a, 2 times 2 is 4, so it's 1. X equals 1. That's our axis of symmetry. Now to find the vertex, we're going to use x equals 1 to find the vertex. And we get y equals 2 times 1 squared minus 4 times 1, and subtract the 3. And to simplify by order of operations, we have 2 times 1, that's 2. 1 times 1 is 1, 2 times 1 is 2. Okay. Then 4 times 1 is 4, minus 3. So we get negative 5 for y. Now let's go ahead and use the y-intercept. Sometimes that's an important point. So the y-intercept, that would be where x equals 0. Y-intercept is where x equals 0. So let's just plug in a 0 here. 2 times 0 squared is 0. 4 times 0 is 0. So our y-intercept is negative 3. Where x is 0, y is negative 3. Let's graph those 2 points. Let's see what we get. Vertex is 1, negative 5, 2, 3, 4, 5. The y-intercept is negative 3. Let's see, what else do we know? Well, this is the axis of symmetry here. We could, well, let me draw a nice pretty line here. Here's our axis of symmetry. And we know that it opens up because the a value in front of the x squared is positive. So we can assume, since it opens up, that we're going up this way. Now, by symmetry, then, we have another point here. And really, there's the 2 arms of the parabola. We might want to pick some other x values, but it gives us the basic shape. And we could also plug this into our calculator and check and make sure that our parabola looks like the one on the grapher. Always plug in and check. You can also look in the grapher point table and make sure that those 2 points appear. I don't think we need another point, do you? Here's another one. Let's find the vertex. Negative b over 2a. Calculate that out. Here you can see I use the formula x equals negative b, negative 4 over 2a, and I simplify that out and I get a 2. So there's my axis of symmetry. Maybe I'll go ahead and graph that first. X equals 2 is here. So then our vertex is going to begin, we'll begin finding it by starting off with the idea that x equals 2. So then we go back to the original equation and substitute a 2 and calculate the y value for the vertex. So here I've substituted the 2 in for x here and for x there. Now be very careful squaring this. You're not going to square the negative sign. You're actually squaring just the x, and the negative is outside. So it's negative 4 plus 2 times 4 is 8 minus 4. So let's see, y then equals 0. So our vertex is at 2, 0, right there. Find the y-intercept, plug in a 0 for x, and you can see everything is going to go away but the negative 4. So when x equals 0, y is negative 4. 1, 2, 3, 4, and then we look and see that the parabola is going to open down because of that negative sign, and it's symmetrical here. So there's our parabola. Here's an example. Now I'm not a medical person, so it's close, but not the terminology I'm sure isn't quite right. If the nurse is listening to this, she's probably laughing, but if you inject a patient with medication, it takes a period of time before the medication starts working and then the medication starts fading, and that's the idea. Suppose that we could model a particular medication with this parabola of y equals negative 3x squared plus 6x plus 2. And then we could use that model to answer some questions. First of all, in order to graph it, we would find the vertex. Vertex we find by first finding the axis of symmetry. So we say x equals negative b over 2a. So negative 6 over 2 times negative 3, which is also negative 6. So our axis of symmetry then is x equals 1. Like this. Here's our axis of symmetry. Now to find the rest of the vertex, we need to plug in 1 for x and figure out what y is. So here you can see I've written the equation substituting 1 for x, and then I simplify by the order of operations. And 1 times 1 is 1, times negative 3 is negative 3, plus 6, plus 2. So y equals 5. So y is 5. 1, 2, 3, 4, 5. There's our vertex, and we know it opens down. So let's go ahead and find the y-intercept, 0, 0, 2. So when x equals 0, y equals 2. And it's going to open down, so our symmetry looks like that. And I can't quite see where it hits the x-axis, and I'd kind of like to know, where does it hit the x-axis? Well, at this point, we really don't have the tools to figure that out, so it looks like it's down here somewhere. Okay, let's answer the questions. What was the strength at the time of the initial injection? Well, if this is your time axis at 0 at the initial injection, the strength was at 2 cc's. What time did the medication reach the maximal effectiveness? Well, that would be on the vertex here, so 2 seconds or 2 minutes or 2 hours, whatever that represents. At where t equals 2, the medication reached its maximum effectiveness. And then what time did the medication cease to be effective? That would be here, where the medication strength runs out. And it looks like it would be between, let's see, this is 1, 2, between 2 and 3 hours or minutes or whatever, it would run out of its effectiveness. So a picture like that can answer a lot of questions.